everybody. Let me get this music off here. What's it? There we go. All right. Welcome, everybody. So, on happen to be on a little vacation in Ohio, and so we're coming live from Kent, Ohio. So, a little different show than everybody else. Hey, John. Hey, Ryan. How you guys doing? So yeah, so we're doing this remote, and I just set it up, and I think I have everything working. We'll see how it works out. But yeah, so I'm up in Ohio, and be back in the shop on next this coming Friday, and then we'll kind of be back to normal um, for a bit. But welcome to the show. Uh, been out since last flew out of town last Thursday, so uh, not a whole lot to update on the shop and the projects we have going on, but um, you know, have to go on vacation every now and then. Hey, Sharon, how you doing? Yeah, so got this working on my laptop. It seems to be working good. I hope everybody can hear me. Everything seems to be, all my meters seem to be working pretty good here. So, um, excuse me, excuse me. So, since I had a little bit of time, I didn't thoroughly test everything out. I had to scramble here the last minute to get everything connected properly, but I did try to put something together for you guys this week. So I thought that'd be pretty cool. Oh, thanks, Ryan. This is working great. Thanks. Yeah, so try to make a real tech tech episode this time. Yeah. Thanks, John. Uh, yeah, so I figured something we hadn't talked about. I was trying to think of something that we haven't discussed about, building cars and trucks and whatnot. Air conditioning. We really haven't discussed anything about air conditioning. We've kind of gone over suspension and alignments and setup and figuring out geometry of suspension. We've gone over brake systems, wiring systems, stuff like that. A lot on engine building and engine tools, and we've even done a bunch on fuel injection. So thought tonight might be a good night. We'll do some air conditioning stuff, and hopefully it'll be something you guys will enjoy. It'll be something we can work on over the next couple of weeks. So we have 6 episodes till episode 100. I'm still working on trying to get some special stuff going for that, but we'll see how that all works out. Um, but yeah, so I figured we'd do some stuff about air conditioning. Now, hopefully, I've got my windows working properly here, and we'll see how this all plays out. So let me go here. I believe this is what we want here. Maybe it's this one. Nope, it's this one. So there's my main page on air conditioning, but that's not what I wanted. I wanted, here's what I wanted. So let me see how we can get that. I think that's on, nope. All right, so let's just see if we can make this work out here. All right, so vehicle air conditioning. This was what they used back in the 50s and 40s, and maybe even earlier than that. It's basically a swamp cooler. It's a tube with gauze or cotton or screening in it with water. Air moves through it, and the air is circulated through the water and blows into the car. And you got cool air conditioning. Now, of course, you had to be moving to make it work. And if you were in a high humidity area, it didn't work as well. a dry area like out in the West, it worked really good because you're adding humidity to the vehicle. I can tell you from having swamp coolers in my shop, anything that is near it will get covered in water and mist, and it can create corrosion on bare steel. So that wasn't maybe the best situation, but um, here's a here's an ad for one of them that they would advertise in like uh, JC Whitney and stuff like that. $14.35. Can you imagine buying a whole unit for that kind of money? Pretty cool. Then they went into I think it was Packard started this unit, and basically uh, basically the same thing. It was a swamp cooler in the back of the car, had vents up here on the quarter panel, and blew air. The faster you went, the more damp air you would blow into the car and create some air conditioning. So, on my little bit of research I did today about air conditioning was kind of a uh, option that a lot of people didn't get a lot of because it was expensive. But around 1969, about 50% cars produced in the United States had air conditioning in them. This is a picture of an aftermarket kit. Now it's building hot rods. This is kind of more stuff what we would see, like a vintage air, old air products or something like that. Classic auto air, and give you an evaporator, condenser, all the main components that you would normally have with an air conditioning. Here's a picture of basically the evaporator. Now I want to see if I can switch back here for a second. Trying to see if there's any. I don't have a real good way of seeing. Oh, my wife is on. My wife and my mother-in-law. How you guys doing? Hope you're enjoying the show. So yeah, so here's like I said, there's a aftermarket evaporator, and the newer modern units will have air conditioning, defrost, heat, all the modern conveniences you'd need for your hot rod. And the way an air conditioning works, just for it's kind of a little lesson here. It's a gas and liquid product that pressure and temperature go hand in hand. So your compressor compresses the hot gases, and it goes into your condenser here, and your condenser has a fan blowing across it, whether it's airflow from the vehicle moving or a fan from your radiator or wherever you have the condenser mounted. You can remote mount them also as long as they have airflow. And that condenser condenses the hot gases to a hot liquid. Now, the hot liquid will pass through a dryer and then to an expansion valve. And the expansion valve, its main job is to control the pressure in the evaporator. You want to keep the evaporator at about 30 psi. Like I said, Freon is a pressure equals temperature chemical. So anytime the pressure drops down below 30, it gets into a temperature zone of freezing, and it can actually ice the evaporator over. So that's what the expansion valve does. It controls the pressure either by temperature or by pressure, and regulates how much flow goes into the evaporator. Now, the evaporator does just what it says. It evaporates the liquid, the low side liquid, it evaporates it into a gas. When that chemical change happens, cold air is produced. And then the cold air, the low side gas then goes back to the compressor, is pumped, pressurized again, which turns it into a high pressure gas, and the system keeps recycling. Little side note, an RV refrigerator works the same way, except for they use just lost it. They use ammonia, and they don't actually have a compressor. They use heat to make the to take the low side gas and turn it into a high pressure gas by heating it. And then it goes through a condenser, through a dryer, expansion valve, through the evaporator that makes it evaporate into from a hot liquid or a cold, low side liquid back to a gas. And that's how a refrigerator works in an RV. But same basic principles, just without a compressor. So this is another design here where you got your ambient air going through the condenser, converting hot gas, high pressure gas to high pressure liquid, and it goes through an expansion valve and through the evaporator. The evaporator blows air from the interior of the car or ventilation air through the evaporator. It evaporates the low pressure liquid into a gas, and that's how you get your cold AC. Back in the earlier days of air conditioning, they had to come up with different ways of doing it. So older GM cars had what they called a POA, and that was to help control the low side pressures to keep it to try to maintain that 30 psi. And then newer cars now use an orifice tube, and that's what this piece here is. An orifice is a fixed orifice, so it restricts the high side liquid down to going through a fixed orifice, which then creates the low side liquid that goes in the evaporator. Now, being that this is fixed, they have to control the evaporator pressure to that magical 30 or over pressure. So on a orifice tube system, you're always going to have a cycling switch. You're always going to have either a high side or low side pressure switch that's going to turn the system on and off by the clutch to maintain that pressure. Because once again, if the pressure drops below about 22 psi, the evaporator will ice over and you won't get any air conditioning. It'll just stop blowing. So on this picture here, they're saying the pressure cycling switch would turn on at 45 and turn off at 25. And that's how it would control your AC. You see your cabin air going into the evaporator at 80 degrees, coming out of the ducts at 50. And you'd have about a 38 degree, the line coming out of the evaporator going into your accumulator would be about 38 degrees. And if you look at the other parts of this, the high side gas coming out of the compressor on this, they're saying about 165 is normal. It couldn't be a little bit higher than that, but right about 165. It goes into the condenser. You got 95 degree ambient air temp going through the condenser, and then coming out will be about 125 because it's pulling heat out of the condenser core, which is what converts the high side gas into a high side liquid. And then the liquid line is usually about 135 degrees. And then again, on the opposite side of the orifice tube, it should be about 38. So this is really important to know these things, because if you have an AC system that's not working correctly, one, you can put your gauges on it. And two, you can use your hands or a temperature gun and actually check the temperature where it's going on. So say you have a condenser that's partially plugged. It got, the condenser was damaged in an accident or some kind of mechanical issue with the condenser. You could have real high side pressure gases, and the temperature will rise. The higher the pressure, the higher the temperature. So you would feel the discharge line, you'd feel that as, wow, it's really hot. And you go to the opposite, the outlet of the condenser, which should be your liquid line, your high side liquid, and then the hose is not as hot. It's colder. Well, that could tell you that you have a restriction in the condenser. Same thing as if you got real high liquid line, high side, and you grab the low side after the orifice tube, and it's not so cold. Well, that'll tell you that the orifice is plugged up. So you can use these things to kind of determine if the system is working correctly. Also, the suction line coming out of your accumulator should be at 38 degrees. So you should see the accumulator frosty or sweating. If it's not, then you know that there's a restriction somewhere, or the system just doesn't have enough Freon in it. So those are kind of quick telltales to see what's going on, to see if anything's work on there. Let me put on chat there so we can see. Okay, so I see Rick saying hi, hey man, how you doing? John says ammonia was the first gas used in the invention of air conditioning. There you go. I did not know that, John. Thank you. But I know ammonia is definitely used in RV systems. Hey, Mike, how you doing? No problem at all. I'm glad you're in tonight. So yeah, so that's where that system, how that system works. So let's go to the next slide here. So the compressor is the heart of the system. You have to have something that's pumping, and compressors have changed a lot over the years. Now this is an older York style RV2 that they would have in like the old Chrysler cars and of the 40s, 50s, 60s, about 70s. They started going to the newer style compressor, but it was basically a crankshaft with two connecting rods and two pistons, and then instead of valves and a camshaft, they have a reed plate, and the reed plate opens and closes, and that's how they create the pumping action. And then they went to the Tecumseh unit. This can be a York or Tecumseh, and this is a little bit newer system. It used a little less engine power to spin. And a quick note, both the RV2 and the York style compressors, these two compressors have a crankcase. They're almost like a belt driven Briggs and Stratton, basically. It's got a crankshaft in it with a flinger, and it's got an oil bath in the bottom, and it flings the oil, and that's how it gets its lubrication. So a lot of people will use these compressors for air systems. Like if you have a airbag system in your car, or air lifts. Off-road guys will use these for air compressor systems, and you can see them on tractor trailers and stuff like that to give the compressed air on all that kind of stuff. And so, being it is self-lubricated, you can use this as a pump for air besides pumping for Freon. John says he's a 608 certificate for residential and commercial AC. Awesome. Well, you already have a pretty good understanding how all this stuff works. Although household is a little different, but it's it's all applicable to the systems. So GM came out later on with the A6 compressor. Now those other two systems were 2-cylinder compressors. This GM came out with this. This is actually a 6-cylinder system, 6 pistons. And what they do is they have a crankshaft that has basically a wave plate. Basically, it's got a journal, basically a throw that kind of is at a 45 degree. So, and then it has pistons that are on both sides connected together, and then with a ball bearing that rides on that plate, and that plate wobbles back and forth, and that makes the pistons go back and forth. This was a very good system. Pumps a lot of gas. It works well. It has a crankcase in it also, but it is very hard. Again, it's a power robber for taking horsepower away from the engine. Then GM came out trying to become more modern. They came out with the R4. Now the R4 compressor the A is axial, the R is radial. So this one is a 4-cylinder, and the pistons are opposed to each other, just like in the A6, but it's radial construction. Now a big problem with these units is this outer shell is stamping, and it goes over a casting with 2 big O-rings. So these had a lot of tendency for leakage. And it was the beginning of aluminum inside the AC compressor, and they would send scrap metal throughout the system. This is also at the same time they started going to uh, fixed orifice. Well, think about this. You have a fixed orifice and you got a compressor that's throwing scrap metal throughout the system. It all accumulates at the filter going into the orifice tube. Now you've got AC restriction and you got big problems. So this was not the greatest system, but I mean, it does work. When they work great. I see Mike says he still has an R4 on his Suburban. Yeah, 95 Suburban would definitely have that. Uh, so that was, that was they were trying to get better and better on the systems. And then, of course, Japan, they take all of our designs and make them better. So this is one of your basic compressors you're going to see in most aftermarket AC systems. This particular one would be a SD 508 and made by Sadin. And these things are pretty indestructible. Again, it's got a crankcase in it, but they figured out how to make the pistons ride in an aluminum case and not have all the problems that the R4 had. It's external casting, so it's rigid, and then the front cover is cast iron, and the reed plate is cast iron. So real good containment. The compressor didn't change sizes, and it didn't have the issues of leaking like the R4 compressor had. So on your aftermarket AC systems, this is a really great compressor. It does draw less power than the R4 did. And of course, in the newer vehicles, as Mike is dealing with at the Chevy dealerships, is now they have variable cubic inch of the compressor. They've actually got a valve size in there, and they can control the volume of the compressor and to take more load off the engine and stuff like that. Of course, with all that fancy stuff comes more issues. There's another Sadin compressor, but these things work really well. You can get them in V-belt and serpentine. The serpentine comes with an 8-rib pulley, so you can run with aftermarket accessories, or you can run a 6-rib and just use the alignment, whether you run the belt to the front edge or the back edge, but it works very, very good. So here's a little schematic I found on a compressor. You can see you got your clutch, your pulley is idler, it idles. It spins with the engine RPM. It does not have anything to do with the compressor until the clutch coil, which is energized by voltage, is energized, which creates a magnetic field and sucks the clutch plate into the pulley. Now, of course, with all these AC systems, clutch air gap is important. You can have a AC system that the clutch air gap gets too big and the coil cannot pull it in, or if the coil is old, it may not have the pull in power that the earlier ones had. So that can always be an issue if you're troubleshooting an AC system. A lot of times, myself, what I would do is I'd take a big pry bar and kind of use it and poke it at the clutch and kind of coaxed it to close that gap and see if it starts running. If it does, then you knew either air gap or the coil was going bad. But it's hard to see on this slide, but the crank guide is on an angle, and that's what makes the pistons go in and out. You've got a reed plate that has a reed going in 2 different directions, one for inlet, one for outlet, just like an intake and exhaust valve. And then you got a manifold in the back that takes care of everything. Here's kind of a more blown up picture. There you can kind of see how the crank has this plate that the pistons ride on. It's not vertical, it's on an angle, and then the pistons have a ball and a shoe, and the piston goes back and forth. So this compressor is a 6-cylinder. Even though it only has 3 pistons, but it has it's pumping on both sides. And here you've got a reed plate on the front, and you got a reed plate on the back. And the reeds, just like on a 2-stroke, when the intake reed is open, the exhaust reed is sucked shut, and vice versa when it's pushing the pressure out, the gas out, the intake reed sticks shut and the exhaust reed opens, and that's how it works. There's no camshaft or anything like that. It's just working by the way the piston is moving. When the piston is withdrawn away from the plate, that's intake stroke. When the piston is driving towards the plate, it's exhaust stroke. And then they'll have these plates on here. You see these plates, and those plates are designed to keep the reeds from opening too far and bending. That's what keeps the thing working. So that's kind of the basics of how the compressor works. Now, like I said, there are some more modern compressors that work differently, but basically all work the same. Here's your R4, and I couldn't find a good exploded view, but there's one piston. There's a piston on the other side. There's a one on the top and one on the bottom. So you got 4 pistons, 2 that are connected vertically and 2 are connected horizontally. Same type situation. You've got a reed plate that is locked in with snap rings on above each piston, and the gases are moved around the outer shell. Like I said, this has 2 O-rings, one on each, on the front and the back of the body, and it's got this shell. I guess that's, but the shell there, oh, I know, I gotta close it down. That was a close. Oh, that's all the picture has. So, but yeah, that's just to show you how the R4 is a radial design. Let me pull the chat back up, make sure I'm keeping up here. So, to control the Freon in the system, you have to have some kind of control valve. Now, on older cars, they used quite a bit of different things. They had some couldn't even explain how a lot of the older systems work. POA was a big one in the 60s and in the 50s. They might have had some other stuff previous to that. Of course, a lot of them had expansion valves and stuff like that. But the POA was a decent system. But of course, all this stuff is calibrated for R12. So if you cannot change the gas that you're using in the Freon from R12 to 134A when you have a real POA valve system, because its pressures are different on the R134A, so they won't work because it'll be controlling everything at the wrong system pressures. Now, they do make these kits that you can take the POA valve off and you put this tube in there, which is sized to fit where the old POA worked. And that gives you, so all your connections will work. And this is a fixed orifice. It's got a fixed orifice inside here. Again, fixed orifice, you need a cycling switch. So there's your cycling switch. And then the other thing on a POA system, there's a oil return. The POA would, because if the oil in the system is suspended with the Freon. So as the Freon's recirculating, so is the oil. But what they would do with the POA system is they had an oil return. They would actually return the oil back to the evaporator core. So they have a connection there. So that's a good unit if you're restoring a car with a POA. This is a way of correcting that issue and still creating it to work. And you could retrofit to 134A and not have any issues. After GM started having issues with the POA system and their space and all that kind of stuff, they came out with this. This is called the VIR. And this is a valve in receiver. So you've got your expansion valve, you got your POA, you got your oil return, and your AC dryer all in one component. And this would stand up vertically in front of the evaporator and work. It was a pretty decent unit. They only used it for a short amount of time. The nice thing was they were rebuildable. You could unbolt this bottom can and change your desiccant bag and your filters for the system. You could take the top lid off. You could pull the pilot valve out or the expansion valve out and replace them. And of course, they now make a accumulator style system so that you can eliminate the POA and go back to a cycling switch with a fixed orifice. So the AC shops have made workarounds on this for your restoration if you're using all OEM stuff. I prefer to go ahead and pull all the OEM stuff out of the car and just go ahead and use an aftermarket system. And we'll get to that in a little bit. So here's your one style of expansion valve. This is probably the most commonly used. It's used in all the aftermarket systems. You have your liquid line going in here, which would be your hot liquid, and you have the low side liquid going into the evaporator through the bottom. And then you've got a capillary tube with this bulb that you would clamp onto your suction line coming out of the evaporator. And what that would do is that senses how cold the suction line going back to the compressor is, which tells this valve that by temperature what the pressure is, and it will regulate. There's a pintle valve in here, and that will regulate the flow, and that's how they control it from making it get too cold and ice up. And then this is another one that also has the oiler section on it also, so it can remove any oil if it wants to. And here's basically how it works. You got your hot liquid coming from your condenser, going around a pintle, and then you got the low pressure liquid going to the evaporator. You have your sensing bulb that goes to this diaphragm. This diaphragm opens and closes this valve by spring pressure. Now you could, back in the day, I don't know if you can do this on a lot of them nowadays, but you could back in the day, you could adjust that spring to change the operating system of the expansion valve. People don't really do that anymore, but it was something that you could control, especially when you were working with R12. And this is one showing the pressure equalization line, just like they used in the POA and stuff like that. You make that a little bigger, but basically it's the same thing. And this is a more modern style expansion block. Now, this is one that you would see in most of your modern cars. It does the same thing. It's just all in one unit. It doesn't have to have a sensing bulb anymore because now it's all internal. You've got your low side suction side here, so it can get the pressure, temperature pressure from inside this orifice here, and then you got your high pressure to low pressure liquid on the bottom, and it pinches and controls it from there. So whenever you have an AC system that's fully charged, got high pressure going into the block, but you don't have cold air, typically this expansion valve has gone bad. I mean, they get a little trash in them. You got oil going through it. Oil starts getting contaminants coming out of the compressor, can clog and jam up the little piston in there, and it creates an issue. So whenever you have, like we showed earlier with the pressures, whenever you had those pressures where you could hold them with your hand or you could check them with a gun, you could see that, oh, the high pressure liquid isn't really getting what it should be. Or you would see really high pressure, depending on where your gauges are set. That's another thing too. Whether your high pressure gauge is before the condenser, after the condenser, or and the low pressure is on the suction hose or on the accumulator, it'll adjust where you go. So you can always check those pressures and stuff like that. But if you have a system that has really low suction power, pressure, and low high side pressure, especially if it's on the liquid line, typically the expansion valve is stuck open and the freon is just traveling through. It's not sitting in the evaporator long enough to evaporate the liquid, and it's not sitting in the condenser long enough to condense the hot gas back into a liquid. So the system is now not working, and your pressures will show it on the gauges. So if you have a system that's not leaking, full of freon, but everything seems like it's right, but it's not blowing cold air, your expansion valve is typically the problem. Orion says, seems like R12 was cooler. Yes, it did make colder air conditioning. Hey, Chris, how you doing? And John says, yeah, R12 was definitely cooler. Yeah, and you can still get R12. I found it on eBay before, and there are drop-ins that have R12 with maybe like I think it's a 410. They have different chemicals that have different freons that they've added or mixed, and it worked really well. But they definitely blow colder than the R134A does. However, a proper built R134A will blow very, very cold. So your fixed orifice system, you can see there's quite a few different ones, and it all depends on where the orifice is. Uh, all these orifices up here to have there's little pointers on this side, the long side of it. Those are the ones that go in the beginning of an evaporator tube. And the ones that have the connector or the grabber on the opposite side usually go into into the liquid line by the condenser. So you got to kind of look around, see where your spots are. You can usually spot your orifice tube because the outside tubing will be crimped. They'll have 4 little dents in there, and that's what keeps the O-ring from going too far. Now you see they have a large screen on the inlet side, and the outside is like a diffuser where the hot liquid goes in, becomes a low pressure liquid here, and that diffuser screen kind of disperses it so it atomizes, I guess, to make the evaporator more function quicker and better. But yeah, you can see here they got all different size orifices: 072, 067, 062, 047. So that's how they control how cold or what the pressures are going to be in the system. And this is just another picture. I thought it was going to be a little better than this, but these are all evaporator mounted. You got liquid line mounted, and you got condenser mounted orifice tubes. So it can be a little confusing on an OEM car trying to find where the orifice tubes are. It really helps to use a shop manual to figure that out. And again, here's your orifice tube, the way it works. You got your tabs for removing it. You got your fine mesh screen to keep particles from the compressor from getting in and blocking this fixed tube. That fixed tube has a different diameter, as we've shown. And then on the outside, they'll have a flow direction, and they'll have a diffuser of some sort, and typically a screen to, again, keep the freon clean. Now, another part of the system that we can't overlook is the receiver dryer. John says airports will pay big money for R12. Works best at high altitude. Oh, I didn't know that. I didn't know that. Yeah, and now we got that R1234, which I don't know if that's how good. I know one of the big arguments with the R134A is that it's more flammable than R12. So that's one reason why they wanted to try to get that out of the car, because it could aid in a fire in a car. It's crazy. When I was a young tech, we would take cans of R12 and we'd take a test light and pop the can onto the test light, and then take it out of the shop and let the can fly, and it would be like a jet engine taking off with all the pressure of the freon coming out of it. And freon, like a lot of gases, as it disperses, it on the opposite side. So the inside of the can is pressurized with liquid, the outside is gas. So it kind of boils the liquid, and it makes it last longer. It's pretty cool how that would really work, but wasn't really a smart thing to do, but I don't know, we all did it. So, and of course, R12, that's still up to debate. It was made illegal to put in new vehicles and in AC units and refrigerators and stuff like that back in the 80s. They were saying it was harmful to the ozone. I've read articles where that has been debunked, and it was more a power play for DuPont, who created the R134A to sell their product. I can't verify that, but take it with a grain of salt. But that seems to be how a lot of this big business stuff works. And that's why you can still buy R12 today. It's expensive and it's hard to find, but it is out there. So that's your receiver dryer. There's another receiver dryer with a pressure switch on it, high side pressure switch. And typically a receiver dryer being is on the liquid side of the AC of the condenser, it'll have a sight glass. And when you had R12, you would charge the system until the sight glass went clear. And you wouldn't just let it go straight to clear. If you're really well versed, you would get it to where it would be foamy and then a couple bubbles, and you just keep barely cracking it a little at a time until that glass went. As soon as you saw it clean, you shut it down, and man, that thing would blow ice cubes out of the system. But all your aftermarket units will have this. All your aftermarket AC units, and they'll have this high side pressure switch on. And what they'll do with that switch is either a 2-prong or a 3-prong, or what they call a binary, and they'll use this to turn on a cooling system fan. So, back in the day when we had mechanical fans on the front of the engine, no big deal. We didn't need all these switches because the fan on the engine was drawing air through the radiator, and the condenser's mounted in front of the radiator, and so it always had airflow. No big deal. Another trick was when we were diagnosing these older systems, and it works on all systems, you would take a water hose and spray it on the condenser to make more condensing energy to condense the high pressure gas to liquid, and the system would get colder. So you could kind of see if it was an airflow issue, because if it got colder with spraying water on the condenser, typically your clutch fan wasn't working properly, or you needed a shroud or something like that. Nowadays, we have electric fans. We don't have fans on the engine. So now we need a pressure switch to tell the cooling system fans that are operated by engine temperature that they need to come on when when the condenser starts getting pressurized. If you don't, the condenser will stop working if it gets too hot. And first thing will be is if you don't have a high side pressure pop off, it'll blow a hose off, and you'll lose all your freon, or it just won't be efficient. If you have enough airflow to keep the high side from not blowing off, but it's not cool, you won't have cold AC. So that's always a good way of testing a car with electric fan. Make sure it's on air. Luckily, some computer systems, we talk a lot about Holly on here. Both Holly and the Excel DFI system had a circuit that you could hook up to the ECU to tell it the AC was turned on, and it would automatically turn the electric fans on if you were using the ECU to control the fans, which was a great bonus. A lot of people don't use that, but it's really helpful to making the vehicle run cool and the AC blow cold. Now on newer cars, we've got all kinds of different looking dryers. These are another style dryer. No sight glass, because on the 134, the sight glass isn't as needed. You do work more on pressures than you do with liquid gas. You won't typically on a 134A system, you will not see a solid clear lens on the sight glass. If you do, the system is typically overcharged. And the newest systems on new cars is now they have the dryer built into the condenser. So when you fix the system and you put a new receiver dryer in, you actually get a cartridge to put into the condenser. And I should have said that earlier. The receiver dryer is the one component whenever you open an AC system up, you want to replace, because it has a desiccant bag in it, and its function is to take the moisture out of the system. Moisture is a big contamination byproduct of the AC system, and it will make all kinds of problems. So you don't want any water on, and that is also why we evacuate the system when we're done working on it with a vacuum pump, because once the system is pulled down over 28 inches of vacuum, it will literally boil the water moisture molecules out of the system and remove them from the vehicle. So if you took a hose and went into a Coke bottle with a little bit of moisture in there and you put it on vacuum, you'd actually see all that water dissipate. It would evaporate and be gone. So that's what we want to do, because when water molecules mix in with the oils, we get corrosion. Your evaporator core is made out of aluminum, and obviously you know that aluminum corrodes with water, and then it'll rot out internally, and you'll have an AC leak. So here's an accumulator, or this is a dryer. I'm sorry, and this is how it works. There's two big desiccant bags in here, or a bag all the way around the tube. The hot liquid enters it. It's got a filter at the bottom to help control some of the oil flow, and then goes back out to your expansion valve orifice tube. Well, expansion valve, you wouldn't run a dryer with it on an orifice system. So here's that'd be like a Chrysler dryer, and there's a GM accumulator. So when they went to orifice, they had to put the dryer in a different position. And so now the receiver dryer is on the suction hose coming out of the evaporator going back to the compressor. And they call this an accumulator because it's accumulating the low side gases and oil and controlling oil flow in the system. There's another one. You can notice the two service valves. So one would be for your pressure cycling switch, because orifice has to have a cycling switch, and the other side would be your service port for charging the system. And here's a cutaway of an accumulator, and it's basically the same thing. You got your low pressure vapor going in, liquid vapor going in from your evaporator, filling the tube, filling the cavity. Once the cavity's full, it goes up and enters the outlet tube. There's desiccant, and you got your filter, and the bottom you got your liquid. And then the compressor pulls out the low pressure vapor into the compressor. And that's why they call this an accumulator, because it's on that side of on the outlet of the evaporator. So it's accumulating the liquid and vapor, because it's not all vapor at that point, and condensing it to where it's all gas, and the gas comes out. And this is why a lot of times if you have a desiccant bag that is full of moisture and you use a AC recovery system, you'll see sometimes the accumulator will get cold and icy and sweat, and the machine will shut off saying it's got all the freon out. And you look at the amount of freon that's come out, and it's not a full charge. 9 times out of 10, the bottom of the accumulator still has liquid involved in it because it wasn't able to withdraw it all, and typically because of bad desiccant bags. So if you see your accumulator sweating, it wouldn't hurt to change the accumulator to make the AC system work better. And this leads us to the condenser. Let's see what's going on here. Mike said R1234YF is what most of our GM vehicles have. Its restrictions to evap and handle it is a pain. Yes, the machines are stupid slow because they have so many procedures just to evacuate and charge. Yes, they are. My wife says, "What is an orifice?" Ryan says 1234 is a pain in the ass, and cost is out of control. You're right, and I almost want to believe, just like the OE manufacturers coming out of with Corks bits and all the other crazy tools and hardware they come out with, I think it's another ploy to make more money. 134 is now made in almost every country in the world. So now, obviously, DuPont or the other big Freon manufacturers in the United States don't have sole rights to making it anymore. So what do? Come out with a new Freon that you have, you can't make for 7 years because it's patent right. They say it was somewhat because the R134 was it would catch on fire if it was in the right circumstance. And they're saying the 1, 2, 3, 4 is supposed to be less likely to catch on fire. Although, if I remember correctly, it's been about 8 years since I went to a class and they were talking about the 1, 2, 3, 4 before it was actually released. And I believe they were saying that this is even more dangerous to breathe than the 134. R12, I don't think had any of those situations. Uh, it wasn't dangerous to breathe. It wasn't fire. It didn't have any fire tendencies. But like the story goes, everybody said, "Oh, uh, global warming was caused from Freon." So I doubt it. Anyway, so this is your old school condenser that you would see like on a early uh, American or Japanese made car, or on your vintage air, or old air products, or classic auto air, any of those systems. Yeah, John, EPA is out of control, always overstepping. You are 100% right. I hope we can finally get some government oversight, get rid of it, because it's crazy. Um, so that's the old school condensers. Now, the condensers, obviously you want to make it, you want the largest condenser you can get in the vehicle, because that takes less airflow to make the changeover from gas to liquid. Cars like your rear engine Porsches, and if you're going to put an AC kit on like an old Corvair or something, they'll use a condenser that goes underneath the car, and it's typically basically almost the width of the car, and usually about 4 feet long. So basically like 6 feet by 4 feet, because there's no fan running on it. There's so much coil surface area, it doesn't need airflow to get that done. Yeah, you're right. Go Doge. uh, but yeah, so that's that's it on the condensers. Yeah, yeah, I see that, Ryan. I've heard that too. That a lot of people manufacturers are going away from the 1, 2, 3, 4 because it's such a pain, in going back to the 134 because it works better. I believe too. So here's a newer style condenser. Um, and let me go back for a second. Here's a good point. Well, actually, this is a newer style condenser, even though it's an old school one. So in these style condensers, you can see that there is all the tubes are going to a common manifold. This is basically a dual pass. So that this manifold on this side is split in half. Let me go to the silver picture, might be better. Um, these style condensers, if back in the day, when we had R4s and stuff like that, compressors, and they would come apart in the car, we would flush the AC system out. So if you had a partially plugged condenser where it wasn't operating properly, you had cold spots in it, whatever, it was a continuous tube. So the Freon high pressure gas would go in the top corner, and it would follow the tubes like your conventional oil or transmission, or oil or transmission coolers do. It would be one continuous copper tube, and then it would come out the bottom. With those, we could send dry cleaning fluid pressurized from a flush can, and we could flush all the contaminant out of the condenser and reuse the condenser. When they went to a single manifold condenser like this, where you have a single manifold that feeds all the tubes, you cannot flush this system. And the reason being is the flush is going to go through the fins that are not plugged, and the fins that are plugged, it's not going to go through, and you won't fix the condenser. So if you see a condenser with solid tube on the ends, and there's a condenser issue, you have to replace it. You can't flush it. Not that, I mean, we're not, a lot of you guys aren't techs, you're not going to do that kind of stuff, but just know that if you're working on your wife's car or your daily or your hot rod, and it's got a fixed manifold, and you want to replace and you want to clean the condenser out, you can't do it. If it's got a fixed manifold like this, you have to replace them. And here's another design. Now, this one you'll see it's got the tube down the side with two little transfer ports. This one, receiver dryer, is built into the condenser. So This is not only the condenser, but it's also the receiver dryer all in one unit. Again, you're not going to see this in aftermarket kits. This is going to be mainly on your new cars. Okay, that was not what I wanted to do. Let me go back here. Okay, so now we've talked about the compressor, the expansion valve or fixed orifice, the condenser, the receiver dryer, now the evaporator. So the evaporator's job is to take your low pressure gas, low pressure liquid, I'm sorry, go into the evaporator core. The evaporator core has air moving across it, which will then evaporate that cold liquid, low pressure liquid, into a low pressure gas, and the air coming out of the fins from the transfer will be cold air conditioning. That's what gets ducted into your car. That's what you get your cold AC out of. This one you can see has got regular fittings for like an expansion valve and a receiver dryer. Here's one with their new style expansion block on it. Here's another one with the new style expansion block on it. And you can see these are all aluminum. So it's very easy for corrosion to appear on these. And I thought I put a slide in here, but I don't think it's in here. The other thing is now most of your new cars have cabin air filters. And the reason of the cabin air filter, yes, it's taking contaminants out of your air coming in the car, but the main reason is to keep the evaporator core from plugging up. Mike uh, can contest, and I'm sure so can John, that when you take an evaporator apart in a house AC, it's got all the dust and build up on the fins, and it will plug up the fins, and then the evaporator will start freezing over. Same in a car. You have a car that people ride their dogs or their cats in the car all the time. All that hair gets sucked into the blower fan and then plastered against the evaporator core, and the evaporator core then becomes very inefficient, and you have an air conditioning issue. That's one thing is when you're working on a car and you're trying to figure out what's going on with the air, you put your gauges on, the pressures are right. You either use your hands or use a temp gun, and you go around feeling the lines, and all the lines feel like they have the right temperature in them, but yet there's still nothing working inside the car. You're not getting cold air. Usually, you can find a resistor card that you can take out and shine a light and get a look at the inlet side of the evaporator core, the blower fan side, and you'll find it being plugged. Now you can clean it with coil cleaner or you replace it, but that can be a problem. But that's also a problem when you have all that stuff on the fins. It's aluminum, and it's not painted or coated or anything, so it can cause corrosion, and the evaporator core will leak. Now your aftermarket AC systems use copper, and except for maybe a solder joint coming free, these will never leak. And that's why when I'm building a hot rod, if there is a under dash modern replacement AC kit that will fit in that car, I will take all that stuff out from under the dash and put an aftermarket unit in every day, because this system will not give you any headaches. The worst thing can happen on an aftermarket AC system is a bad crimp or a pinched O-ring. Other than that, those systems work, and they do blow very cold air. The core on these are very cold, are very thick. So even with the R134A, you can get these things really to blow very cold out of the vents. So here's we were talking before about pressures and temperatures, and you can see here you got ambient air temperature. So let's say it's 86 to 95 degrees. That's kind of where we're all at. And you got three different areas for relative humidity. It all plays a factor in there. And you can see how dry air, the low side pressure will be between 28 and 43, and in a high humidity, it'll be 32 to 47. So it changes the pressures. Same as the high side pressure will go from 146 to 205, And then on the high humidity area, 160 to 213. So that is always a change in the vents. And also you can see here the difference in ambient temperature. So you got 86 to 95 degree air going in, you got 54 to 58 coming out the vents. So that just shows you. And obviously, when the ambient temperatures get higher, the air conditioning blows, the discharge temperature will be higher also. So those are things to keep control of. A lot of tool truck guys will have a AC tester that will have two thermometers. As one you put uh, like under the wiper blade to get ambient air temp, and you put the other one in the center vent of the AC, and it shows you ambient versus discharge temperatures, and it will give you a go no go kind of thing. You can see the differences. Typically, you should see close to 40 degrees variance in a good working system. Here's a 134 chart. And the pressures you can see here at 90 degrees, look at the pressure differences, where the Freon R12 would be between 28 and 40. R134A is going to be between 45 and 55 psi, and the high side is going to be 250 to 270. So large disparity between the two gases. They definitely work differently. And John knows, doing residential and commercial AC systems, every gas has their own targets of where you want to go. So John says, so Ryan says, yeah, sorry, we already went over that one. John says there is a new gas for home AC, another pain in the butt. Yes. I kind of dealt with some of that too. We just had a new system put in. Both my shop and my house both have that new system in there, and they have temperature glide charts to properly fill them. Correct. That's basically what these charts are here. You kind of got to look at the chart, see what your ambient temperature is, and that's going to tell you what your low side and high side pressures will be. And if I remember correctly, the high side pressures on those newer Freons for commercial and residential are like another 20 degrees higher than what these are. So I'm guessing. I don't work on that stuff. I just was watching over the guy's shoulder when I was looking at when he was working on the system. And it's just another 134 chart, but again, shows you basically the same thing. So that leads us up to a new thing that you can do for your hot rods. And I might do this on my Vet Hawk. So when we came out with the advent of the hybrid cars and now electric cars, we don't have an engine to spin the AC compressor. So we have to come up with another situation. So just like you have in your household and residential commercial units, you have a electric motor compressor. So that is a thing now. So you can take a electric compressor. There's another system, and these are pretty readily available. Actually, these pictures actually came from Amazon. There's a picture of the compressor. So this compressor, you can bolt anywhere in the car you want. It doesn't have to be hooked up to the engine, so it doesn't have to be in the engine bay. You hook up your discharge and your suction lines to it, and the rest of the AC system, as you would of any other kind of setup. And you have an AC system that doesn't require a belt off the engine, so it's going to blow cold whether the engine's idling or off or whatever it is. So when I was preparing these slides, I was thinking about that, and I thought that would be pretty cool for my Vet Hawk project, because obviously, being an autocross car, I'm going to be very concerned and try to be as appropriate as I can on where weight is placed in the vehicle. So we want the weight to be John says up to 500 psi on a new Freon. Yeah, it's crazy to have 500 psi system, 500 psi of gas or liquid running through your house. But yeah, so this electric compressor got me thinking. It's like, this would be really cool, because now I can put the compressor behind the driver's area. I can put the condenser in the back of the car if I wanted to not interfere with the cooling system of the engine, and uh, move the weight around to the car to keep the car more 50-50%. And being whenever you put a standard car on scales, you'll always notice that the driver's side is always heavier because you have a human sitting on the left hand side of the car if it's a left hand drive car like our cars are, and the right side of the car will be always be lighter. So, we always try to move the battery to the driver passenger side. If there's an oil canister, oil, if you're running dry sump, you want to run the oil tank on the right hand side. You want to put anything you can on the passenger side of the car to balance the car front to back and left and right. So this is going to be something I'm going to look into on that because I can move that stuff around. John says you can have heat also with a four-way valve to make it a heat pump. Okay, well, I didn't know that. That's interesting. Uh, but yeah, so this is where sometimes modern stuff can be a pain as far as making hybrids, and us hot rodders, like, who cares about hybrid? We don't want anything to do with it. But out of that comes some cool innovations that we can use that would make it pretty cool. So a buddy of mine, guy John, it was an auto painter, and he had a third gen, actually it was a fourth gen Firebird, and back in the day, we built a motor for it. And we talked about this when we were talking about power steering. He wanted the engine bay to look like a drag car. He only wanted an alternator on the engine, but he still wanted power steering in the car to make it drive good. And that's when I went ahead and used an electric power steering pump, and that way the engine, when you open the hood, it looked like a drag engine because it didn't have any accessories on it, just an alternator, low mounted, and just looked very racy. Well, you could do the same thing now. His car didn't have air conditioning because he didn't want the compressor running off the engine. But now you can put the electric compressor on there, and now you can have AC and not have it on the engine either. Ryan says he's going to use electric power steering on the Vega. Yeah, and I'm going to do the same thing on the Vet Hawk, because I am going to I'm going to do a dry sump on that engine, on the main engine. So I want to keep the accessory drives to a minimum. John says it reverses the flow and makes heat. Very interesting. I wonder if these automotive electric compressors do the same thing, because they had to make heat for these cars. And if you don't have an engine running, I know full electric car, the batteries or the batteries have a cooling system on them, because the batteries, as they're charging, make a lot of heat. So they have a cooling system to kind of control the battery temperatures and stuff. But yeah, if the compressor would reverse and make heat, that would even be way cool. So yeah, so those are just some things I wanted to go over. I figured since I wasn't in the shop working, I had a little bit of time, I'd try to come up with something that would be educational and shed some light on something that we all have to work on. Most of us live in a region that we want air conditioning in our hot rods. So it's good to know the components and how they work. So maybe next week we'll get into some of the stuff, other parts of the air conditioning, like hose crimping and stuff like that. And I'll come up with some stuff. I will be back in the shop on Friday, so I'll have a couple days in the shop, so I'll be able to put some stuff together. And like I said, I'm trying to get these things more technical, like we did in the earlier shows. But I appreciate y'all logging in. Thanks, Ryan. I'm glad we're all able to get in and enjoy. Hope you enjoyed the show and learned some things about AC. And we'll go from there. So with that, I guess I'll see y'all next week. See ya.